start. I will try very hard to just stay here in one place. That's not how I usually do my talks, but I guess I'm bound here. Um, Thank you for coming. Thank you for inviting me in to give a talk here. I'm going to talk about a piece of work that I had done a couple of years ago, and it resulted in this book, Exercise in Programming Style. Um, I'll tell a little bit about how I converged to this, but it all comes down to some inspiration from Heart History Simplified, which is that there are many ways of drawing a face. And not only there are many ways of drawing a face, but interestingly enough, some painters, some artists have developed their own sort of stylistic approaches to design in general, right? You can recognize, you can look at a certain piece of art, and you can recognize certain elements in there that gives away about who the author or the artist was. I think I don't know about you, but in my sort of alter life as a software developer, open source software development, when I'm develops the a very large code base that I'm involved with, I can look through the code and I can see who wrote that. Everybody resonates with this experience. You can tell, right? You can tell the people who come from a C background, a very sort of embedded systems engineering. You can tell their code. You can tell people who work for IBM. I can tell people who work for IBM. Uh, you can tell people who are trying too hard to kind of impress, or kind of a tendency to over-engineer. You can tell who the people are. So there are these styles, but there's something about what the style is. What is it that makes a style, right? Why is it that we can recognize these styles in code out there in the wild? And furthermore, where else do we see these things, and why are these things important? So programming styles are ways of expressing the tasks. They exist in many scales, and that's the part that I find quite interesting. They are ideas for how to divide the problem into parts and how to put the parts together again. That's very, very many ways. That's sort of a very strong component of a style. It's not just whether you use capitalized letter or whatever. That I don't that's is also part of the broader definition of style. But the part that I'm actually more interested is in the ideas for dividing the problem into parts and put them parts back again together. And there are many ways of doing this. And you can see these ideas repeating from a very small scale, a very small programs, toy examples, all the way to distributed systems. How do you partition what you have to do, and how do you make the things talk to each other? And you can see the same approaches, the same styles recurring at these different scales, right? My question was, let me tell you my personal why I came into this. I tend to teach programming intensive courses at the senior level, not at sort of the introductory programming level. I don't teach introductory programming. But one thing that I realized when I was looking at the code written by students that are in third, fourth year of an undergraduate degree in computer science, I saw a lot of really bad stuff, right? It's just like some of it is really, really, really ugly. And I started to realize what are we teaching, right? What are we teaching the students that they come into almost ready for a job in the job market, and they're writing code like this? And how do we teach them, right? It's a matter of communication. How do you communicate these ideas, these stylistic ideas? And this is kind of a very important problem for us academics. We teach, but it's also an important problem for everybody, because it's a problem of communication. And now, you can approach this from a sort of a very pure sort of mathematical perspective and say, okay, the way to, minimize, be as minimal as possible, just encapsulate that whole thing into a small little thing that you can use Greek letters for, and this is the pure knowledge that everybody has to assimilate. That's one way of doing it. My experience is that the path to get there, to be able to actually assimilate those kinds of formulations is so high that most people will not be able to assimilate, and they're missing a lot of interesting and important knowledge, including for their professional careers. So I started to realize, well, how can we teach these things? And so these are things that we are that we know after maybe 20 years of programming experience. We've been exposed to a lot of these different styles, a lot of these different ideas, and we gained a lot of baggage. Is there a way that we can kind of package this and teach people? How do we do that, right? How do we teach people monads, coming from the previous talk, without teaching them category theory? Right? How do we monads in independent category theory? They're a really interesting, cute little stylistic way of thinking about dividing things and putting them back together. Right? So how do we teach that? And I'm talking about monads, but it can be anything: actor style, map reduce things, you name it, everything that we come into contact as we develop code. So that was my problem. How do we communicate this? I didn't know. And then by chance, one day that I was thinking about, I was actually Googling. I came to the word style because I thought it was an interesting word. And then I Googled, I think I Googled programming styles or something, and this came up. This author came up. Does anybody know Raymond Queneau? 1, 2, 3 people. Okay, 4 people. All right. So he's an interesting writer from 19. He peaked about 1940s. A French writer. He was part of sort of this group of intellectuals in Paris, writers, mathematicians, musicians. The French style kind of. And he wrote this book called Exercises in Style that I immediately ordered from Amazon, because it had exactly the right title, and I was really like, it blew my mind. So it's exactly what I want, right? This is, if I was studying to be a writer, professional writer, I want to do this. And basically, let me tell you what this is. This is a book that. Written by Raymond Queneau, that takes a very stupid little story. It can be told in 2 paragraphs. The story is completely trivial. There's nothing interesting about the story. Some guy who takes the bus and notices some other person on the bus, and then later on meets that person in some plaza, and that's it. That's the end of the story. But he tells the story in 99 different ways. Right? In different kinds of ways of telling the story. So he tells the story with metaphors, lots of metaphors, surprises, lots of surprises, very precise. He actually doesn't name the styles, but as you read through, you can immediately see what, you can identify some elements that he uses that makes the story different from each other, because they have different renditions of the same story. So this is like, wow, this is exactly what I need, right? I need to find a stupid little story, simple little program that everybody knows how to do. The algorithmic complexity should be out of the way. Everybody should know how to do that. And now let me illustrate the wonderful, rich history of programming ideas, and just with exactly the same program. And hopefully, if I could pull it off, with exactly the same programming language, so that we remove any variability out of the problem, and the only thing that varies are the ideas for how to divide things and put them back together, right? And how, or the stylistic ideas of the problems that you encounter while programming, and how you can solve them. So one of the things that Raymond Queneau and his group of intellectuals in France did, their big thing was this, their definition of style. Okay, the definition of style actually was quite technical. Style for them was something that emerged after you impose certain constraints. Okay, so let me give you an example. Has anybody read this book, Avoid? In French is Disparition. Okay, so Georges Perec was one of the people in this group. And what's interesting about this book is that, the history itself is interesting. It's actually history of some, actual story of somebody who disappears and something. But more interesting than the story is the fact that the book, both the French version, the original French version, and the translations, I read the English translation, was entirely written without the occurrences of the letter E. Okay? I think the only occurrence is the name. But so you can imagine that if you self-impose a constraint like that, right? The E being such a, a dominant letter in almost all the languages, you're going to fall into interesting idiomatic expressions, very strange idiomatic expressions that you normally wouldn't use because you have to avoid words like the, for example. So the whole book feels a little bit off, that something is missing because of these constraints. That's their idea, is that the idea is that style is not something that it's not related to inspiration or whatever. It's something very technical. I mean, you just put stakes on the ground. What is it that you can do? What is it that you cannot do? And style is what emerges after you try to do something with those constraints. I find this idea brilliant. Okay, it's very simple. It explains a lot of things also for us. So basically, this is exactly what I did. I just copied this idea. Um, so here's my story, my little story. Term frequency, which is take a file, a text file, parse it into words, count the occurrence of the. I also added exclude the stop words. So exclude like the and things like that. I have a list of stop words. Single letter words also excluded. And after you exclude those, count the occurrences of all the words and write out the 25 most frequently occurring words. Okay, so everybody knows how to do that. Every undergraduate after a year of programming knows how to do this, right? So algorithmic complexity is non-existent. And so, for example, if you feed it through Pride and Prejudice, which is my test book, you'll end up with something like that. Okay, this is the output. So I give all the students, here's your output of your program. So there's nothing more to it. So the book itself is divided roughly into 9. So I wrote the book. I didn't do 99 different ways, otherwise I would never finish. But I did 33. It doesn't mean that I covered everything with 33. In fact, there's some more that I thought about that would be really nice also to have, but I stopped after I imposed myself a time limit for publishing the book. I grouped these 33 different styles into roughly sort of things that are related. So there are historical styles that cover things like the old times machine learning when computers were not very powerful and you kind of had to worry about memory and things like that. Basic styles are things like procedural, the basic functional approaches and things like that. There's objects and different types, different ideas of objects and object composition, reflection, adversity. There's a part on data-centric styles, which I like very much. Concurrency, and then some styles for interactivity. So these are all sort of roughly the 9 sort of groups of styles in those 33. So what I'm going to do for the rest of this talk is I'm going to just pick a few of them out of the book and just go through them, okay? Just so that you have an idea. So you all know what the task that I'm doing, term frequency, okay? So here we go. So this is style number 3 in my book, I think, if this is in sync. You don't need to zoom in. This is it's good that you see it zoom out. This is the entire program, okay? By the way, I used Python in the book as sort of the base language for everything. Even, obviously some of these styles are not Python stylistic, right? I'll show you which one is the more Python one, but I just used Python as the common language, so to remove any complication about syntax and things depending on the styles imposed by the languages. So not just Python is great because it's just really very agnostic to a lot of things. Okay, so this one is one style, and you'll see. Let me zoom in a little bit. Over here, you have on the top. There's a couple of sort of global variables in a way, the state, some state in there. You have state for for actually computing the word frequencies, for you yank out the stop words. And so the word frequency, the first one is the one that actually accumulates the pair's word frequency. And then you basically go into a nested loop, iterating through the lines of the file, and in each line you iterate through the characters of each line, and then you might imagine what goes on in here, right? This is basically logic for identifying the beginning of a word, the end of a word, checking whether the word already exists in that dictionary that is not even a dictionary. But that's basically the logic control flow that's going on in here. That's sort of a those are supposed to go away. So all the punctuation goes away. That's part of the specification of the problem. So, all right. Let me tell you, just by you looking at this layout over here, if you were to want people to write code that looks like this, what constraints would you tell them? No abstractions. Good. Maximum nesting, maybe. No return statements, yeah. No comment. Yes. There's some comments in here. Don't load the whole thing in memory. That's a very good one. That's a very good constraint. That's a very interesting constraint that actually resulted in this kind of style being one of the earlier styles. Right? We got this style because the earlier computers could not hold a lot of data in memory. Right? So this is not the style in my book that represents that better. The one that represents that better is actually style number 1, which is exactly that. But this one also gained from that historical background that you cannot hold, you should not hold the whole text book in memory. So it only holds a line at a time, which is an interesting constraint, right? So, but yes, so basically is I've heard, so it's basically no abstractions, no functions, either your own or others, right? You're just doing everything here and right now and then. Um, and another constraint might be that you have to be very careful about memory, right? So that you only hold a little bit at a time. So that might be constraints that you might give to people, and if they observe those constraints, they would end up with code that looks like this, right? And you might think, well, this code is horrible, and probably you might be right for this particular problem. But on the other hand, there are certain circumstances where, in fact, you need to worry about memory consumption. That this is the thing that you just need to do, right? So I'm being relatively agnostic throughout the whole book. I'm trying to describe what's good about this and what's bad about this, but trying to stay away from giving very opinionated prescriptions about you should not use this or you should use this, right? So yes, no abstractions, no use of other functions. So I call this one the monolithic style. And the reason is that if you try to observe these constraints, you end up with a lot of importance on the control flow and the logic of what needs to happen, because you're really sort of constrained over there, right? You don't write it in sort of a higher level of abstraction, but you write everything down there. It's too low level, so you end up with control flow being like the dominant action going on in here. All right, so let me move on to another one. This is style number 6. This is it. Okay, this is the entire program. So it's so much so that I can actually zoom in and you will see the whole thing. Okay, so here it is. I'll let you read. Okay, so so here's the thing. I did not write this program. I wrote a version of this program that was actually much uglier than this, and I had it on my GitHub account. And when one morning, I opened my email and I had an email from Peter Norvig, and I was like, "What?" One of the most interesting emails that I have ever received in my career was just like 8 lines of Python code, okay, and the first two were comments, and the comment was, "Mine is shorter." This is his version of term frequency, which I found out, wow, this is beautiful. This is what you write in Python, basically. This is the Pythonistic way of doing this. So you get the stop words, and then in one single line you read everything out of the text file, you normalize to lowercase, you have a regular expression that filters everything out of everything that is not character, letter, or that is less than 2 characters. That's what that regular expression does. And then basically and then you use that very powerful collections library that I didn't know it existed. Right? So Python has a really good collections library that does almost everything for us already, right? So it just counts the occurrences of the words that are not in the stop words, and then it spits out the most common 25. It already has that function most common, right? So this is absolutely beautiful. So I'll just show you, out of curiosity, the version that I had that was really ugly, which, by the way, was also not done by me. It was done by someone who's here at the conference, and he gave me this solution the first time that I presented these ideas a few years ago. But this is slightly uglier in that it doesn't use the collections library. So it has to use some like hacks in here with the sorting, how to sort to rank the words, the word frequency, and this lambda comparison over here. And this not only is uglier, but it's super slow. Because basically every time that you want to rank some word, you have to count everything again. It's just like absolutely horrible. Okay, you run this and it takes about 10 minutes to process the Pride and Prejudice. So anyway, but it's short, right? So if I already told you the key, if you wanted somebody to write code like this, what would you tell them? What constraints would you tell them? Concise as possible, right? As few lines of code as possible, or as few characters. That's a version of it. So I already heard the term that I call this style, the code golf style, right? So
So don't you think that his version is kind of not fair because he just or this collections library that he's using, that's the same as put everything in some other library, and I can make a one-liner.
yep,
Just
absolutely. Yeah, that's a very good observation. Absolutely, you could reduce this to one line. If you already had a library that does exactly the term frequency specification that I said.
Sorry, in your specification, a composed word that has a dash inside, is it a one word? Because
Uh,
this version wouldn't catch them as.
it would they would be split
So
in 2 words. Yes. So 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 basically, you would say as few lines of code as possible. Also, an interesting thing of this style and some constraints that you might want to express is you reuse or use as many third-party library functions as you can, or core library functions as you can. Right? Use already code that does already what you need. Right? That's a style. And that's an option in many cases. That's a very important decision that people in companies have to do. Should I write my own, or should I use something that somebody else already done? Right? That's a really important strategic decision. And you see those kinds of decisions even at this small micro program level too. It's the same decision. And it's pretty much the same trade-offs. Right? Okay, so code golf style, or try hard style also. Okay, so style number 4,
sorry, I would call it idiomatic code. What
idiomatic for Python.
yes.
Yes.
What would the perfect expert write
Yeah.
in that code?
Yeah, but that's kind of a moving target. Anyway, so let's go to this one. Let me just zoom in. This is about a page and a half, and you will see what is going on in here. There's a pool of shared data over there. There's some. division of tasks going on in here. And then the main method over here says it all. It's basically, you know, read file, filter, normalize, scan, remove stop words, etc. Right? So you've seen this before, right? We've all seen code like this before, right? There's a pool of shared data over there. There's a bunch of these procedures over here, and the whole program consists of basically issuing commands that transforms the shared data. Do this, then do that. It's like a recipe, right? This is a style that was very much sort of at the center of the structured programming movement. Structured programming as opposed to unstructured kind of go-tos and assembly language and all that stuff. This is sort of the beginning of thinking about dividing things neatly. Um, so again, think about what's really at the core of writing programs in this style. What would you tell people? Mutable states, yes. No, yes, no argument. Sorry? No composability, no return values. Okay, somebody's plugging me 5 minutes. I have a lot of styles to go through. Let me go through some more interesting ones. So it's basically what you all said. Basically, the larger problem is solved by dividing into these procedures, and you have to explain what the procedure is. And the computation proceeds by applying one procedure after another, like a recipe. So this is a very sort of natural way of programming that a lot of us kind of grew up with, um, and I call it the cookbook style. Um, Let me go to this one. This one is almost the same, almost, with some important details. And I must apologize because I had to shorten the names of the functions here because I really wanted to put it all in one line and it didn't fit. But these are supposed to be the shortened versions of those names over there. Okay, so you kind of all recognize this style. Yeah, so it's pretty, sort of a functional style-ish. So the idea is that you divide the problem. There's no global state. Okay, we got rid of global state. The idea is that the problem is defined, is subdivided into smaller problems. Each one maps to a function as in a mathematical function. You take input and you produce output. That's it. And the way that you compose the program is by composing functions, as in mathematical composition of functions. That's basically what this is over here. And just for fun, I just decided to put the very last thing for printing out. I decided to go out of style and just print it out in a loop. But that's just to tell you that I'm not completely obsessed about style. This is another one. So you just have to explain this idea of designing programs as compositions of functional abstractions. You have to explain that actually this tries to mimic the idea of functions as in math, and that's how you just proceed from there. So I call it the pipeline style. I didn't call it functional style because I got into all sorts of trouble when I tried to call it functional style. But pipeline is I think a fair word for this. All right, so okay, this one is a cute one. I'll just go. I'll just look at the signatures of these functions, okay? And of course, Matthias is here, so we'll know. But uh, who dares to tell me what this CPS? Yes, continuation passing style, right? Which I absolutely love that the people who have been doing functional programming have the right word for this. It's continuation passing style. It's a style of writing programs, right? It's a style of organizing your code. And they had the right word many years ago. And so you basically, I don't need to explain this because half of you already know. And let me move on. I'm time limited here. Basically, take one parameter. All these functions take the additional parameter that is called at the end. All right, what is this? Okay, just pretty much, pretty much. This is basically, so I can go to describe what this is, but you can already kind of see, right? You divide the problem into these entities, and they tend to be entities, right? They tend to be nouns, and you have end up with all these managers and counters and things like that, and controllers and so each one has their own methods, and each one can encapsulate data that you're supposed to access only through these methods and whatnot. So you end up with an object-oriented style that is very much Java flavored. So in my book, I actually have very many flavors of objects. There's not only one flavor object at all, right? If you go and program in JavaScript, which is also an object-oriented language, you have a completely different flavor of objects, right? So there's also a style in the book that covers more the Java style, the Java script style of objects. Uh, all right, so which one is this one? I'll skip this one. This is another version of of, um, of objects that is more like the actor-like objects. So this is the idea that the objects they basically only expose one thing, which is give me messages, right? And then there's a dispatch method inside them that dispatches the messages. Okay, so this one is fun. Okay, and it will give this, the last part will give it all away. This is the main method, okay? MapReduce, right? And term frequency is a wonderful problem because it can be done in so many ways. There's like no ending for how you can do MapReduce. It's the most flexible problem ever. So MapReduce, there's variations of MapReduce too. Um, of course, you have to explain these abstractions of map and the abstraction of map and the abstraction of reduction. If you want people to write programs like that. And in this particular case, the problem needs to be amenable to this kind of treatment, right? Not all problems are map reducible naturally. Okay, this one's also fun. So what's going on in here? What's going on in here is that now you're in a different kind of context, right? So I told you that I wanted to do term frequency, but maybe what I really meant is that I want to analyze my data. And one of the analyses that I want to do is counting the words of the file. But maybe I want to do other analyses, unbound. I don't know which ones, but in the future, maybe I want to count the number of words with Z's, or the number of words in which two vowels occur, or something like that. Okay? So now the problem is slightly changed under me in the sense that I've decided that maybe I just don't know everything that I want to do. Maybe the data is more important. And this is, by the way, part of the data-centric styles of the book. Maybe the data is more important. So maybe I should pay more attention to the data and how to represent the data so that it's amenable to exploration in the future. That's where these kinds of relational models come from, is that the data is actually more important than the computation that you make on it. And so in this particular case of SQL, you kind of have to figure out, well, if you're going to explore the data in sort of open-ended ways, maybe having the data as a flat text file on disk is probably not the best way. So maybe you have to have a different kind of representation for your data. So let's parse the data and put it in this interesting relational model that is amenable to these queries, relational queries that are really nice. And so that's what's going on in here. You just parse the file, put it in a bunch of tables. I have here a table for documents, a table for words, and a table for characters with the obvious relations between them. And then there's one SQL query that does term frequency for me. That's this one over here. Okay, SQL is great. So in order to end up with programs that look like this, you have to explain a little bit of this idea of where does this come from and why would you want to do this, and what is this idea of having a query engine, right? Because you need a query engine, and you also want to have declarative queries. All right, so in other words, I'm coming to the end of the talk. I've only presented 5 or so styles here. There's 33. I didn't even present my the ones that I like best. One that I like very much is the spreadsheet style. Okay, and this leaves you as an exercise for you. How would you do term frequency in Excel? Okay, exercise for you for this evening. But the take home really is that there are many ways of solving the problems, and in particular, the problems that I was most focusing here is the problems of writing code. And in particular, not so much the algorithm, which there's lots of interesting things about how to code efficient algorithms and all that stuff. That's great. We know how to teach that. There are texts, lots and lots of textbooks about algorithms and data structures. That's great. What we have not been paying much attention is how to actually write the code that both does those algorithms, interacts with the outside world, interacts with other pieces of code, right? So, and in particular, what I think that sort of I have zoomed in for a long time is that how do you structure your thoughts, basically? How do you structure the code? How do you divide the problem? How you put it back together? And there are many ways of doing that, many, many different ways. And I would like people to have a very large spectrum of these ideas on their back pockets when they go out to work in industry, because they will find these things in the code that they will encounter that already exists, and they will probably need some of these things as they write the code too. They need to understand that there are these constraints that their coworkers have been operating when they join. They need to understand what those constraints are and how to write to those constraints. They need to be able to talk about different kinds of constraints and negotiate them well. So all of this is really what I believe is the core of programming and teaching programming, and actually people know how to program, being comfortable with all these ideas, right? Knowing how to apply them, knowing what they're good for, what they're not good for, and not being stuck in just one way of doing things, which was what I saw in those students coming into my upper division courses. The ones that had started with Java, they were completely stuck in Java. The ones that had started in whatever, they were completely stuck in whatever. It's just like you could see, right? And there was this lack of flexibility in their thought about programming that really, really kind of scared me. And like, we need to fix this, right? We need to stretch people's abilities and skills and this is really what I think is the core of programming, basically, independent of algorithms and the wonderful things that we do with programming. So that's it. You can contact me either at UCI or can tweet me. Thank you. So there's time for questions.
So, is it working? Do I need it? Just speak loud. Okay. So,
can I ask you a question? Years ago, there was a website called PK. Somebody reminded me of this on a project workshop. And it was psychology and programming, roughly the interschool. And they had queried managers of programmers, and they came to only one conclusion. The quality of programmers directly depends on how many paradigm switches they have gone through.
That's really interesting.
So that's unfortunately that website was taken down. So I can't quote it directly with the URL. But if that if we believe, if we accept this, isn't it our fault in universities for teaching the monoculture of Java and Eclipse or whatever is currently fashionable in producing students who are not able to switch along those 30 styles?
Absolutely. That was my conclusion too. I mean, I felt that we needed to do something. We were not teaching people well if we're just teaching them one way of dividing the problems in, that's just, it's terrible because there's so many ways.
Your alma mater is better.
Yes.
okay, so even though learning about different paradigms is important, and you try to be impartial, it was even from your talk kind of clear that there was a really best way to solve the problem as specified, right? The Peter Norweg way. So wouldn't you say that in most cases, if you do understand all the requirements, there is actually one right way to do things?
Um, Maybe.
Python, yes.
Maybe. I mean, maybe. So yes. So this. I mean, the example that I give here, and the data file that I give as an example, which is the Pride and Prejudice book, is sufficiently small that the problem is so constrained that Peter Norvig's way is probably the best way of doing this in Python. There's no question. But if you think about that, now you're actually processing many books, not just one book. You're processing millions of books. Now Peter Norvig's style doesn't actually scale to, you can do better with things like MapReduce and things like that, right? So but yes, when you are able to constrain the problem so much that it's very clear that there's only one way to do it, then there's only one way to do it. That's only one best way to do it. Yeah. Yes.
What was the impact on your teaching? How did the students react to that?
So I created a course based on this book. I teach it at the upper division, so basically seniors, undergraduate seniors, and the younger graduate students too. The course is basically the same, except that graduate students also need to read the historical papers where all of these ideas emerged. But the course goes like this. It's 10 weeks, and every week they have to do an exercise. And the exercise consists in taking a couple of these exercises and writing them in whatever other language they want. So, except Python, which is already here. So, write them in Java, write them whatever. And so it's been, I taught this course already several times now, maybe 4 times. And so I've been teaching for 14 years. Uh, Usually the students like me in general. I mean, I have a good, tend to have good teacher, student evaluations. But for this course, I've gotten consistently the max because students really, really love it. And the comments that I get is like, wow, it's like the students are ready. They are at a point that they are ready, right? They know enough about programming that they don't get tangled up about how do I read the file, right? But and then they are ready to kind of trying to explore other things. So this has been really very successful the way that my experience in teaching this material. So um, that has been my experience. They like it.
Sorry, this is not actually a question, just a comment I would like to share with you. I have been thinking in how to teach a style for a few years also. I have also read the elements of a style and think about it from the same point of view. So I think that styles appear as a solution to very precise problem. So when you have one problem, you develop one style. When you have another problem, you develop another style. And in the university, we are teaching solutions without presenting the problems, without making the students suffer the problems. So whenever you teach the solution to a problem that that person has never had, then the solution comes by one ear and goes by the other without any kind of appreciation. So actually, I will think that actually teaching the problems and then that particular solution will improve a lot the education system, I believe.
I agree. But I think that more than the problem is actually the constraints. If you just make the constraints explicit, the students will find they will have no option but converge to these styles. They will have no option because they have to solve a puzzle, right? I say you cannot do that. Oh, okay. Now I have to do it in another way. Now I have to think, right? So they will find it eventually.
Do you find that there are some styles among students that they prefer over others, or they find more usage than others, or even the industry going forward? Are there any styles that you think more useful?
So the question is if I think that there are some styles that are more useful than others, or that the students like more than others, or that they are more useful for industry, for their careers in general. So those are different questions. So depending on the students and how comfortable they are with programming, I've seen that there's two types of students that go through my courses. There's one group of students who stick to the only other language that they know. So this is all in Python, but so if they know Java, they do the whole thing in Java. And then there's another group of students that take this opportunity to actually learn languages that closely match these styles, right? So there's two different kinds of students. with respect to the styles that I think are more useful, what I've heard from students, they really enjoy learning about the concurrency styles and the MapReduce styles and the data centric styles too. So the ones towards more the second half of the paper, and I especially the master students that take this course, some of them are professional. They are professionals. They work in companies, and they think, wow, this is exactly kind of what I needed to consolidate things that I see in my work that I hadn't really take the time to think about it before. So more the later ones of concurrency and data centric ones.
So yeah, just a quick comment on getting back to the um, comment that there was one best style, and maybe to Matthias's comment as well. So maybe that style came about exactly from the ability to combine many styles or have a wide understanding of different styles and different paradigms.
Yeah,
So
I
that's
think
really
right. I think
why.
it's important that it's important to understand all what are your options, right? It's without if you don't know what your options are, chances are that you are kind of shooting in the dark. You're just going with what you know, and maybe the domain of what you're doing is so narrow that what you know is all you need. That's great. But in if for most people who switch domains or who do different things, they end up encountering problems that they haven't encountered before. And if they're not aware of all these other ways of doing things, chances are they make the wrong decisions in their code. Well, okay, so I think we have to wrap up. Thank you. At these different scales, right? And my question was, so let me tell you my personal why I came into this. I tend to teach programming courses, programming intensive courses at the senior level, not at sort of the introductory programming level. I don't teach introductory programming. But one thing that I realized when I was looking at the code written by students that are in third, fourth year of an undergraduate degree in computer science, I saw a lot of really bad stuff, right? It's just like some of it is really ugly. And I started to realize what are we teaching, right? What are we teaching the students that they come into almost ready for a job in the job market and they're writing code like this? And how do we teach them, right? It's a matter of communication. How do you communicate these ideas, these stylistic ideas? And this is kind of a very important problem for us academics. We teach, but it's also an important problem for everybody because it's a problem of communication. And now, you can approach this from a sort of a very pure sort of mathematical perspective and say, okay, the way to, minimize, be as minimal as possible, just encapsulate that whole thing into a small little thing that you can use Greek letters for, and this is the pure knowledge that everybody has to assimilate. That's one way of doing it. Uh, my experience is that it just that the path to get there, to be able to actually assimilate those kinds of formulations is so high that most people will not be able to assimilate, and they're missing a lot of interesting and important knowledge, including for their professional careers. So I started to realize, well, how can we teach these things? And so these are things that we are that we know after maybe 20 years of programming experience. We've been exposed to a lot of these different styles, a lot of these different ideas. We gained a lot of baggage. Is there a way that we can kind of package this and teach people? How do we do that? Right? How do we teach people monads? Coming from the previous talk, without teaching them category theory. Right? How do we monads in independent category theory? They're a really interesting, cute little stylistic way of thinking about dividing things and putting them back together. Right? So how do we teach that? And I'm talking about monads, but it can be anything. Actor style, map reduce things, you name it. Everything that we come into contact as we develop code. So that was my problem. How do we communicate this? I didn't know. And then by chance, one day that I was thinking about, I was actually Googling. I came to the word style because I thought it was an interesting word. And then I Googled, um, uh, uh, I think I Googled programming styles or something, and this came up. This author came up. Does anybody know Raymond Queneau? One, two, three people. Okay, four people. All right. So he's an interesting writer from 19. He peaked about 1940s. A French writer. He was start. I will try very hard to just stay here in one place. That's not how I usually do my talks, but I guess I'm bound here. Um, thank you for coming. Thank you for inviting me, Jan, to give a talk here. I'm going to talk about um, a piece of work that I had done a couple of years ago, and it resulted in this book, Exercise in Programming Style. I'll tell a little bit about how I came to how I converged to this, but it all comes down to some inspiration from Heart History Simplified, which is that there are many ways of drawing a face. And not only there are many ways of drawing a face, but interestingly enough, some painters, some artists have developed their own sort of stylistic approaches to design in general. Right? You can recognize, you can look at a certain piece of art, and you can recognize certain elements in there that gives away about who the author or the artist was. I think I don't know about you, but in my sort of alter life as a software developer, open source software development, when I'm develops the very large code base that I'm involved with, I can look through the code and I can see who wrote that. Everybody resonates with this experience. You can tell, right? You can tell the people who come from a C background, a very sort of embedded systems engineering. You can tell their code. You can tell people who work from IBM for IBM. I can tell people who work for IBM. Uh, you can tell people who are trying too hard to kind of impress or kind of a tendency to over-engineer. You can tell who the people are. So there are these styles, but there's something about uh, what the style is. What is it that makes a style? Right? Why is it that we can recognize these styles in code out there in the wild? And furthermore, where else do we see these things, and why are these things important? So programming styles are ways of expressing the tasks. They exist in many scales, and that's the part that I find quite interesting. They are ideas for how to divide the problem into parts and how to put the parts together again. That's very many ways. That's sort of a very strong component of a style. It's not just whether you use capitalized letter or whatever. That I don't that's is also part of the broader definition of style. But the part that I'm actually more interested is in the ideas for dividing the problem into parts and put them parts back again together. And there are many ways of doing this. And you can see these ideas repeating from a very small scale, a very small programs, toy examples, all the way to distributed systems. How do you partition what you have to do, and how do you make the things talk to each other? And you can see the same approaches, the same styles recurring, part of sort of this group of intellectuals in Paris, writers, mathematicians, musicians, the French style kind of. And he wrote this book called Exercises in Style that I immediately ordered from Amazon because it had exactly the right title. And I was really like, it blew my mind. So it's exactly what I want, right? This is, if I was studying to be a writer, professional writer, I want to do this. And basically, let me tell you what this is. This is a book that written by Raymond Queneau that takes a very stupid little story. It can be told in 2 paragraphs. The story is completely trivial. There's nothing interesting about the story. Some guy who takes the bus and notices some other person on the bus, and then later on meets that person in some plaza, and that's it. That's the end of the story. But he tells the story in 99 different ways, right? In different kinds of ways of telling the story. So he tells the story with metaphors, lots of metaphors, surprises, lots of surprises, very precise. You name. There's not. He actually doesn't name the styles, but as you read through, you can immediately see what You can identify some elements that he uses that makes the story different from each other because they have different renditions of the same story. So this is like, wow, this is exactly what I need, right? I need to find a stupid little story, stupid little program that everybody knows how to do. The algorithmic complexity should be out of the way.